Hey everyone, welcome back to my channel, and this is the next video wherein we are going to do an amazing question of binary tree. Yes, in this video we're going to be creating a binary tree out of pre-order and in-order traversal which is given to us. So if you know what in-order and pre-order traversal is, and if you don't know, then you can watch my previous video wherein I had created binary search tree out of these two traversals which were given to us. There is a twist in this question. Basically it's not asking for us to create a binary search tree, because if that would have been given, the approach would have been different, and that is just a simple thing that we just need to keep on checking with the ranges that where exactly the node is gonna fit, right? That's how we can do that from the in-order and pre-order traversal. Okay, so in this question we are not supposed to create a binary search tree, we are supposed to create a binary tree. So there is going to be a different logic that's going to be used in order to solve this kind of a problem. So I'll be explaining you the logic that how exactly you need to approach this particular problem, and basis on that we can do this particular question. So without further ado, let's get into the logic. So basically, as you can see, what are the things which are given to us in this question? There are two different arrays which has been given to us. As you can see, that int pre-order and in-order array which has been given to us having certain elements. Definitely they belongs to the same binary tree. So we just have to use that piece of information in order to create a binary tree, and in return we have to return something called as post order, I believe. Let me just take a look. So basically is a pre-order traversal and in-order traversal the same tree construct, return the binary tree. Yeah, so we just have to return the root itself at the end, and that's going to be a tree node that definitely it's having return type as tree node. So we just have to return that piece of information, and then we are done with this question. So let's try to understand what basically we can do in this particular thing, that what exactly is the logic we need to use so as to solve this particular problem. Okay, so let me give you certain information that how you can do that. So let's try and write down certain information: 3, 9, 20, 15, 17. Okay, so this is a pre-order. If you know that what exactly pre-order is, so the pre-order logic is going in such a way that the very first thing which is given to us is gonna be something called as node, and then after that it will be left, and then after that it will be right. So this is something called as a pre-order traversal. So that means if this information is something which we already know, then this 3, the very first element, it's definitely gonna be the root node, right? So this is something that we know. Now what do we need to do next? So this is going to be my root node. This is something which I know from the pre-order. And the next thing that we need to take a look, now that we also have this in-order traversal in our hand, we can also use this information. We can utilize this piece of information as well. What we can do, we can just take a look on this 3 number inside of this in-order traversal. The reason why I'm saying is that because in-order traversal is something which we know that's going to be left, n, and r. This is something that we know from the in-order traversal. So that means whatever the node that I have in my hand, I can just check the in-order traversal from there. If 3 is going to be something placed over here, whatever the element that I will be having at this particular location and at this particular location is going to be the left and right nodes of that particular node. So now that I know that this is going to be my root node, I can check the same information inside of this in-order traversal. So now that I know this 3 is belonging over here, so that means 9 is going to be the left node, and 15, 27, these 3 elements are going to be on the right hand side of this particular node. This is something I can conclude from this in-order traversal. Okay, so let's try to write this piece of information. My 9 is going to belong over here. This is something that I know from the in-order traversal. And what all 3, 15, 20, and 7, these 3 are going to be belonging to the right hand side, right? 15, 20, and the number 7. This is something which I've got to know. Okay, so now I can do this thing once again, because over here I can see that only one element is there on the left hand side, but now on the right hand side I have 3 different elements. So I need to do the same process again. I can perform the next, I can just check for the next element, this 9, and for this 9 again I can look into the in-order traversal, which is going to be number 9, and it is not having any of the element on the left hand side. So that means we are done with this particular node. I can move forward. I can check for the number 20 now. The number 20 is going to be again looked up in this in order traversal. I see that 20 number is basically having one node on the left hand side and one node on the right hand side, which is left is having 15 and the right is having the number 7. So I can conclude that piece of information as well. So that means this 20 is going to be having certain things in such a way that 20 is going to be my node and the 15 is going to be on the left hand side and the 7 is going to be on the right hand side. This is something I can include out of this particular information, right? So I believe that makes sense and it's going to be a little bit understood by you. So basically you don't have to do, you can just, let me re-explain this particular thing, that how you need to have this kind of a thought process in order to approach this kind of a problem. We are just given two pieces of information, pre-order and the in-order traversal. We don't have any other information. We just need to use that piece of information in order to conclude, in order to build our whole binary tree. How we can use that piece of information. The very simple thing is that pre-order is something that we know the very first element is going to be the root node, right? This is something which we know. Once we have that root node with us, we can approach and we can use the other information that we have, which is in-order traversal. In-order traversal is something moving in such a way that it's having left, node and right. So this is something that we know. Now that we know that node is something that we have got from this piece of information, which is pre-order, we can look at its left and the right side, because that's going to be the traversal. That means whatever the nodes that we have got on the left hand side of that particular node is going to be belonging to that place only. That's going to be located on the left hand side. So 9 is not having so 3 is basically having one node on the left hand side. So that means on the left hand side we'll find 9, and on the right hand side of the 3 we're going to be finding something called as 15, 20 and 7, right? That is something which is concluded over here. By using this information we can approach this particular problem. So let's proceed further and write down the code of this particular question. Okay, I would say that code is also something going to be going with the flow. If you have got this piece of information, then you can simply write the code all by yourself. So let's proceed further. Okay, so basically we're going to be creating a new method in order to create our binary tree. So I'll just name this as my binary tree and I will be passing all the information. So okay, so whatever the output that's going to come out of this particular binary tree is going to be itself going to be my node. So that's the reason I'm just simply typing it over here. So the piece of information that I need to pass is pre-order. I also need to pass the in-order. I also need to pass on the index of the in-order. So initially, at the very initial point, I will be just passing on the 0 index, 0th place of the in-order array which is given to us. And the next thing which I'm going to be passing is in-order.length -1. So that's going to be the final location of my in-order array that I have. So let's proceed further and write down next thing, binary tree, and that's going to be accepting certain inputs. So it's going to be having the return type as tree node, because that's what we're going to be returning at the end of the code. And let me just copy this, whatever the information that we're going to be getting from the main method. So this is going to be having something called as my arrays, and also it's going to be having the lowest index as well as the high place. That's what it's going to accept. And the next thing what we're going to be doing is over here. Okay, so let's just go with the thought process that what we were trying to do. So the very first thing which we were trying to do is that, okay, so there is also one variable I need to have in order to keep the count of the index of the pre-order. So I'll call this as pre-order index. Oh, let's just keep it as in short, pre-index, and that's going to be initialized with 0. So let's proceed further. And the very first thing which we need to do, firstly, we're going to be creating the node, and that to be from the pre-order, right? Because we know that whatever the first element that I have for the pre-order array, it's going to be my root, right? That's going to be my first node for the tree. So for that thing, what I'll do, because now that I have created a node, I need to use the pre-order array. So that's going to be pre-order, and also I need to use the very first element that is placed inside of this array, right? And that's going to be having certain index. So that means pre-index is something that's going to be pointing to the very first element, and that's going to be incremented after every execution. Okay, so let's proceed further now. Next, now that the node has been created, I need to check for this particular data that I've got from the pre-order inside of my in-order. So how can I do that? I need to check the index of that particular location. So I will call this as in order, and that's going to be index. So I'll create a separate method for this, which is going to be my search method. And in that search method, I need to pass on something called as the in order. And I also need to pass on the node dot data, whatever the data. Okay, so that has to be val. And the next thing I need to do is I need to pass on this low, and also something called as a high. So these low and high are basically going to be used for the in order array that we have. So let's create this method first, and we'll see that how we can proceed further. So it's going to be returning the integer. So I'll call this as search, and yeah, that's pretty much it. So firstly, I will call this as nums because we are just having an array, and I will call this as my target element, and that's going to be something called as low, and that's going to be something called as int high. After that, I need to use a for loop that's going to be searching for all the elements over here. So that's going to be starting from int equals low, the lowest location that is there, and this is going to be something called as high, and after that it's going to be incremented. Okay, so now we need to check if at any point my nums I is equals my target element, then I can certainly return my index, right? That's pretty much done. So after that, at the end, I just can return anything like of my choice, which is going to be -1, because we only bothered about the index that we have for the in-order traversal. Because just rethink about this particular thing, that whatever the element that we have used for from the pre-order array that we had given, we're going to be just checking for that particular element inside of the in-order array that we have, and we have passed on this in-order array, and definitely that element has to lie in between of the low and high index, right? Once that's done, we got the index, we can proceed further with our logic. And now what do we want to do? We want to create the left and the right node of this particular thing. How we can build that? So now we're going to be creating and calling this method recursively. What all piece of information we need to pass on? Firstly, we're going to be passing the pre-order. We need to pass on the in-order. And what's going to be the low? Just think about it, because we are working on the left hand side of this particular node. So definitely the low is going to be the same. But talking about the high, that's going to be changed, because we are going to be looking at the element which is on the left hand side of the in-order index that we've got. So that means whatever the in-order index that we have got, we have to subtract -1 from there. I hope that makes sense to you. We're going to be doing the same thing for the node dot right. We're going to be calling the same method, which is binary tree. And what do we want to do? We want to mention all the things in order, pre-order, and this time we will be having certain different things, because we are working on basically something called as the higher side. So that means it's going to be having the highest point as the same one, but talking about the lowest side, it's going to be in order index +1, and high is going to be the high, right? That's pretty much it. Once everything is done, we can just simply return something called as our node at the end. And also we need to define the base condition, because as of now we haven't defined anything as a base condition. So what do we need to do? So the very first thing which we want to check is, just imagine for a fact if low becomes greater than that of high, definitely we want to make that node as null, right? And now imagine for a fact, after creating this particular node, if you come to a particular point wherein your start becomes equals to yeah, so that's basically the low. If low becomes equals high, then definitely you wanna return something called as what? You wanna return your node. I hope that makes sense. I will explain the code once again in brief. After, let me just check if everything is set. Definitely it's gonna pass the test. Yeah, let's try to submit this. I hope that will definitely gonna be. Also, there is some error that we've got over here. Tree node. Let's take a look. What's the error that we are getting? If low is greater than that of high, we definitely want to return null. And if tree node pre-order, let me just take a look, because error shouldn't be coming. Okay, so basically pre-index is going to be incremented every single time. That's going to be low, return null. And pre-order, pre-index is going to be starting from 0. If low is equals high, return node. Pre-order index in order low and high equals. So this particular thing is basically comes certain like many other times, but it shouldn't be coming over here. Alright, so let me tell you that what exactly the error that we were getting in this particular code. So it was just nothing, like when we were trying to search our element inside of this in order array, which we've passed to this search method. So basically this was not given as equals to high, because it can also be the case whatever the element that we are trying to locate itself is at the highest index. So that is also something needs to be included in order to return this particular value, and then after that it's gonna definitely pass on all the test cases. So let's try to run the case, and let's also try to submit this particular code. That's definitely gonna be accepted over here. And now that I'm gonna be trying to submit this particular code, it is definitely has been passed. Okay. So let me explain you certain things what I have used as a logic for this particular question. It's a very, I would say that an easy logic that we have used. So previously when I mentioned everything about this particular logic that you have to use these two arrays which are given to us. Firstly, just look at the pre-order and then try to look at the same element which is there, like at what particular index it is located inside of this in order array. That is something which you need to keep on looking. So I would suggest you to just go for the dry run for this particular code. I'll mention everything in the description box. If you'll do the dry run, you will have more clarity for this particular question. Let me just explain you the code that how we have tried to proceed. So inside of this main method, we haven't done anything. We just simply return whatever the value that we have got from this binary tree. So we have defined a index that's going to be pointing to the pre-order array location and the elements of the pre-order. That is going to be starting from the 0th location of the pre-order array, and that's going to be pointing to every single element that is going to be there. Okay, so that's going to be passed, and that's going to be used inside of this binary tree method. So we have passed on all the elements, pre-order, in order arrays that we have, and also the location of the starting point and also the last point of the in order array. That's what we're going to be using. So now that has been passed, this method has been just started over here. This is basically the base condition that we have mentioned over here. So the base condition says, just imagine for a fact that you have reached to the point that in order positions, the lowest and the highest points are basically crossing each other. That means it has been crossed and you're not going to be finding any particular element, right? So that doesn't make any sense. So you just have to return null at that particular point. Next thing is that we are just starting with the function. We are just starting with this method. We are creating the very first node, that to be from the pre-order index that we have started with from the 0th location. That's going to create the very first node of our method. And imagine for a fact that you have reached, that's not going to come initially, because initially you have defined this as 0 and the last location. So that's not going to come at the very initial point, but that's going to come at after using, certain recursion. So that it will be more clear when you will do the dry run for this code. So we will be just searching for that particular element, that whatever we have created for this node value. So we are passing that to be for the search method, and the lowest and the highest index, because this element has to be in between the range of the in order lowest and the highest index. Otherwise we'll be just returning the null. That's not going to come to reach this point. It has to be, you know, within the ranges. So that will be searched inside of the search method, and that will be returned back the index of that. And basis on that, we'll be going to be creating the left and the right node, because we know that inside of this in order traversal, whatever the node that we are checking that we've got from the pre-order, and all the elements on the left hand side, there's going to be something going to create the left node of that particular node, and also the elements to the right hand side is going to be creating the right side of the node. So that's what we have done. We have passed on the pre-order and the in order, and the lowest and whatever. So low is basically going to be the same for the left hand side, just like the way we do the binary search, right? From the middle element, whatever the node that we have, we do it with the -1, mid -1, and starting from the low to mid -1. That's the same thing which we have done over here as well. And basis on that, we're going to be getting the values from the in order data that we've got. Okay. And at the end, we're just returning the node. So that clearly just something, you know, we are returning at the end, whatever the node that we have got to this method back, and that's going to be returning our binary tree. I hope that makes sense. I hope the code is pretty much clear to you. If you have any kind of a doubt, you can definitely mention that in the description box. And I would suggest you to watch my previous videos wherein I've explained creating a binary tree from the pre-order and also the in-order traversal. That's going to little bit help you to build the logic for this question, because it's a little bit similar. You know, all these type of the questions are basically in the same range, because we are creating a tree eventually at the end, right? So I hope that makes sense, and I hope a little bit of logic for this question is clear to you. If you have a doubt, you can mention that in the description comment box, and I will also mention the code for this particular question in the description box, and to my link that to the GitHub repository, so that you can have a look on that one as well. All right guys, so thanks for watching. See you next time.